Okay. In this question, we are given two loops. Now they are formed using wires. They are both insulated from each other, so they don't touch each other. The area of the lower loop is 2A. The area of this upper loop is A. The magnetic field is given to be such that it is cutting into the plane, right? So now we have to talk about the maximum net induced EMF. So of course we have to do that. To be able to do that, we have to be able to write first of all the flux, right? So it is given that the magnetic field is B here. So what we can assume is since these are open loops, the direction of area is on you to decide. So what we can do is take the downward direction as the direction of area vector, right? Now phi is equal to B dot A, right? So if the area is in the direction of B, you can of course say that phi will be of the form BA into cos of theta, where theta is the angle between the two. Now what you were given is that at t equal to 0, you start rotating this system about this common diameter, right? So once you start rotating it like this, you know that theta will vary as omega into time, right? So flux for the first loop will be B into A into cos of omega t, right? Flux in the second one will be B into 2A into cos of omega t. So you can find the EMF induced E1 will be derivative of this, which is BA omega sine of omega t, right? And E2, the EMF induced in the second one, will be B into 2A into omega into cos of omega t. Now, you clearly see that both have the same sign. The EMF induced for both is the same. So, that means they will not add up but subtract, because they will both try to circulate current in the same direction. For example, if the direction of circulation is this, then the direction of circulation in this loop is also that, right? So you can see that net EMF will be the difference of these two, which will be when you subtract these two. So they are both supposed to be sine. When you differentiate cos, this will once again come to be sine. So when you subtract the two, you get BA omega into sine of omega t. So once you get this, you can see that option D is clearly incorrect, which says that the EMF is proportional to cos of omega t. It is clearly proportional to sine of omega t, right? Then the EMF induced in the loop is proportional to sum of areas of the two loops, which is not correct. It is the EMF induced in the loop is proportional to sum of area. So when we say the loop, we talk about both the loops, right? Right. So of course it is not proportional to sum, but rather the difference of the two. Then we have option B, that rate of change of flux is maximum when the plane of the loop is perpendicular to the plane of the paper, meaning it has turned by 90 degrees. So we are talking about the rate of change of flux, meaning the induced EMF. So sine 90 is 1. Of course, let's look at this expression. So since flux was this, EMF will be of the form BA into sine of theta into d theta by dt when I differentiate this, right? So you can clearly see sine theta will become 1 when theta is 90. Therefore, this option is correct. Which also reminds me of this fact that E is minus d phi by dt, but I am dropping that minus sign conveniently because here we are not concerned much with the direction. Right, then comes the option 1, which says the amplitude of the maximum net EMF induced due to both the loops is equal to the magnitude of maximum EMF induced in the smaller loop, which happens to be true. E net is BA omega sine omega t, and in the smaller loop you also have BA omega sine of omega t. So both of them are equal. The only key thing here you have to be able to identify is that when they rotate, the circulation of current You can understand that let's look at the initial situation. The flux was inwards, right? Pointing out of the screen for you right now. So when you start turning this, flux in this direction is decreasing, right? So use your right hand rule and see that you want flux in this direction. So circulation of current will be this, right? And that will also be the direction in which EMF is induced. So you want current flowing like this. Now what happens is that for the lower loop also you have the same direction. So once again we have current trying to flow in this direction. So you can see the direction of currents is opposite, which is because the direction of EMF is opposite. So the net EMF you will get will be the difference of these two.